First, thanks for coming to the presentation. Actually, yeah, this is a brief story of my journey in 3D printing, but not in terms of like professional additive manufacturing services. But the story continues on my journey of making my circuits and machines and things. So it's a little bit different in that way. Actually, everything started in 2008, 2009. At that time, we were working together with a glass artist and an interior designer, and we were making stained glasses with a specialized technique of my partner. And then we were thinking of the process, like it was too labor intensive, so it took too long to make even a simple thing. Okay, the results were beautiful, but the process was so hard. So then I thought like there has to be a way to automate this process in a way, or maybe make some tool to make it easier. And at those times, there was economic crisis, and also we were thinking of making a product rather than making stained glass panels. So we passed on to making mirrors, applying that technique onto the surface of mirrors. And in the beginning, yes, it was too hard with doing by hand. So I asked for some companies to make a machine, a CNC-based machine. Maybe we can do something like that, I thought. And it was costing about 30,000 Turkish liras or so on a single machine, and there was no guarantee of whether it will work or not. So, yeah, in terms of my search for automation, I came into the RepRap project in 2008 or 9 or something like that. And I thought that it might work for us, since it works similar to our technique. Then I ordered MakerBot Electronics Generation 3, for those who remember. And then I tried to search for forums and groups, YouTube videos. I think the YouTube is a university by itself now. If you like to search for things. And also I went to, obviously, Austin for some parts that we needed. And I made most of them by my hand, taking aluminum profiles, making some things from Legos in the beginning. Then it changed, but so the result was we made a brand called Mirror Fabrica, and this was like an introduction video of that. And also the obviously you made a website. I'm showing these because like the appearance of these seems to be professional, but now I'm going to show you the background of that, so it's a little bit funny. this was the website. So. And the background is like this. Actually, there's a toy here. Toy, and all the parts are made from standard aluminum profiles. These groovings are manufactured in Austin, and these it also works with air pressure. So there are some components related with them. These are regular bearings, linear bearings. Stepper motors, everything is normal. And these are the normal L-shaped profiles, aluminum profiles, very cheap. Because one of the most expensive parts in these machines are the linear motion systems. They are like, we need to have a machine that is in the size of like 230 centimeters to 160 centimeters. So if you consider such a size, the costs related with the linear motion were too high. And also, yeah, this is the previous part that I showed. These are the material feeds. And yeah, make robot electronics. And this is the first machine that I did. Okay, this is the version 4 or 5 on the same table, but this is the second machine that I made, which is much smaller, but it works much faster. And the funny thing is, like, this part is taken from a CD-ROM drive bay. This is the part that holds the laser that reads the CD. This stepper motor here is taken from a printer, and this wooden part is cut in this machine, and this is all the same. And this is a profile that is used for glass balconies that are made in Turkey. It's something similar to that. So with these machines, these two machines, we make such things. Like, this is 220 centimeters height. This is the one that I showed as the first slide. That was a render. This was the real product. And also another special thing about this technique is, like, the surface is not stair-stepped. The surface properties of the mirrors are perfectly smooth surfaces. That's because of a specialized post-process that we use. So these surfaces start to act like magnifying glasses on the surface of the mirror. This is another example. And also it allows such, this is not bumped like this, but this is an optical illusion with the lines, transparent lines on the surface of the mirror. The height of the lines are like 1.5 millimeter height, but because of the optical illusion, it seems like this. And also, this is from a series of mirrors that are planned to be manufactured for an exhibition called under the title of Enslaved. So during these things that I was trying to do, I also tried to make a master's thesis in industrial design. Actually, the things that I researched in that thesis was, what are the effects of the additive manufacturing to the design profession, industrial design profession? Because for most of the time, this is not a new technology, but for most of the time, it was used for prototyping reasons. So it started to progress into the phase of using it for end-use products. But how it affects. So my focus on that thesis was the usage of these technologies in terms of manufacturing end-use products, not prototypes. So you will obviously you obviously see many examples related with 3D printing, 3D printing this, 3D printed this, that. So after some point, it starts to lose its point, because I believe that it has the potential to change the way we perceive products, because it allows us also to control the inner properties of objects, the densities, inner mechanisms. Of course, there is the part complexity is one of the most important advantages of 3D printing. But for now, in terms of popular culture, it is used to promote ornamentation for now. Of course, there are some studies, researches going on in the background, but for now, it's the main thing that is going on. But for example, this is this part is hidden inside the object. So when you squeeze it, it becomes like this. So these will allow us to transform the things that we do, the way we manufacture objects, the way we consume objects, the way we create technology or new things, the way we innovate. So the reason that I showed my previous experience with the Mirror Fabrica is that it allowed me to try things very cheaply, because I made things all by myself. So if something goes wrong, I can immediately do it again with a cheap part again. You don't have the fear of what happens if it breaks, what happens if it fails. So you can continuously make new things related with that. So you can expand the capabilities of the thing that you do. You can experiment with new ways of doing things. So that was my things that I was searching for. And this is a diagram from my master's thesis. In the thesis, I interviewed with several industrial designers that used this process, rapid prototyping, as an end-use product, and they made an exhibition. They are called Barbar designers. They are mainly located in Istanbul. And the rapid prototyping has this problem of, like, you get something out of the machine, and it is a finished product and an intermediary product. It is both at the same time, and you cannot progress it from there. So if it's a finished product on the left side, the object cannot be modified, and if it's an intermediary product, the design process is continuing. Thus, it becomes a verification product rather than an end product. So it is contained in this loop-like thing in a conventional understanding of rapid prototyping. It's now changing, obviously. And also, as industrial designers, the relation with the technology should be, I believe, like not looking from the outside to the technology, or like, for example, buy a 3D printer, make things that machine allows you to make, and nothing more. Only, obviously that has a very high potential also, but I think that the way to change things lies through involving in the making of this technology, in the progress. How can I say, deriving things from this technology. So I think that will change many things also. So with that, from the master's thesis, I had the question of intervening into this perfectionist process, because one of the designers that I interviewed with from the Barbar designers, he told me that this is such a perfectionist process that after you hit the print button, there is nothing meaningful that you can do to intervene into that process. So it becomes so untouchable that you start to lose the relation between material, tool, making, and all these physical connections. So that was a problem hanging in my head for a while after the master's thesis. So when I started the PhD here, this project that I will show you is made for a physical design course. That was the idea was to use physical object to intervene into this process. Like, for example, you can take a hammer and hit the head of the machine, but that will probably not result in a meaningful object. So it will only not functional changes. So what with the tools that we have, that we are familiar with, we have the ability to intervene into the process. That was the question. So I decided on plugging a basic one to the head of the 3D printer. These are all these things are needed for plastics. But because of the work that we do not have anything related with plastics, so I did not try plastics, but rather than silicone, clay, chocolate, and such materials. So this is maybe silicone, regular silicone. I was thinking of using sound as a intervening project, so the tool becomes basic. I plugged the basic element into an amplifier, and the amplifier connected to the solenoid coil with magnets in them. Yeah, first I had to make some tests regarding the. I decided to make a regular cylinder just as a test object, just to see how the process of the object varies with the things that I create. Then I tried some. Yeah, the previous slide was without sound, without any sound, just to make it still like that. And we are done with some audio loops. Mainly bass. Why bass? Because so then I passed on to the live session of Yeah, this is the one that I played. I messed it a lot. Yeah, the question here is like not to create a beautiful object and things like not to create product obviously. But this project made me realize that we can use object sources as a recording medium. Like it records the sound and the performance that you make, and it in a way has intricacy in itself. So what would they mean is another topic of research which continued on that direction actually. So it also connects a physical interface that we are familiar with to the manufacturing process, and it also modifies the object without completely destroying it. So it, in a way, uh, in, force your performance onto the surface of the object. It makes the object malleable or something like that. So these are the result metrics. This is the test cylinder. These are the other ones. So in between these things, I was also trying new things. Actually, I did not have much time, but this was a portrait try that is not so well done with chocolate. These were the type tries. I was not thinking of making any complex tries because actually I did not have time. Sorry? Chocolate. The wire, the coil there heats the chocolate in this syringe. So it's like a rather sensitive process because if the chocolate temperature is just below a certain amount, it clogs the nozzle, so you cannot make it. So this is a really thin nozzle, medium nozzle, regular. Like years or something like that. So now the temperature is above the normal or above the optimal temperature, so it collapses. It should be slightly less. Also, there are two fans cooling the extruded chocolate here, computer fans, but yeah, sometimes they don't work that well. Actually, you had to optimize the system after doing it, but I didn't have that much time. So I also tried the insulation silicone that you buy for 5 euros, something like that. This one is supposed to be an absolute 3D product, but after some time it collapsed because the wall starts to become like collapse slightly in the previous layer. So when it passed on top of that, it failed completely. And also it was related with the input amount. The input was not sufficient to hold that in place. There should be a type like Apollo 3D. Became absolute fail. But I actually like to include it in the style of the process, so I kept it and showed it. This was done with a much thinner layer height and thickness. This was also one of the tries. And this was, they stick well to the windows after being cured, so they make nice window ornaments. Very simple things.
As I dance upon the waves of a waking dream, as it fades in.
Other than this was the most interesting project. This was done for Britain University's chemistry department. This is a little more technical one. They developed some special catalysts that are used to filter poisonous gases, and they developed some technologies on top of them. So, in order to test these catalysts, they purchase monolithic structures that are mainly made from ceramics, and they dip that ceramic. That ceramic parts are like a cylinder with tiny channels inside, many channels. So they dip that object, that monolith, into the catalyst solution, and they get it out, and they put it and get it out, and they fire it in between these processes. So they call it dip coating. So the catalyst forms a surface on top of that monolith that covers it. So we were thinking of increasing the efficiency of these monoliths by increasing the surface area inside the monolith. For example, for that, this is not so obvious in this first try, but the channels go twisting inside that monolith. So you cannot make this in conventional manufacturing, but additive manufacturing, 3D printing allows this. So we decided to try that. This is more straight one. This is made from kaolinite. It is high temperature ceramic. So it was fired at 1,200 degrees Celsius. This is the regular clay. It glass liquefied in a way, but those are fine. So that was another project, and now I'll show some examples from my clay experiments. This was done for a sustainable lighting project for the course, Children. Actually, I'll show you in the later slides, but first I'll show some forms. This was like a knot going through each other. And this was among the first tries with the clay, so it worked well. Not so well, but it can be optimized. And this is literally the first try with my first try with clay. Actually, clay is a beautiful material because it can carry its own weight. Obviously, if you go too high or too wide, it will obviously collapse, but it allows to an extent to do many things. So worth exploring, I think. So this is another object. The normal containers don't have that much clay inside, so I made another container, a pressurized container. A lot of water pipes. Again, cheap. So this was for that project, sustainable lighting, for the course for that design for sustainability. So the idea of this lighting lampshade was, okay, out of clay we make things, and we fire them and we use them. But this project integrates ready-made object with this lamp base, which is bought from IKEA for 10 liras or something like that. And it is combined with a clay lampshade. And that lampshade is, after being manufactured, isn't fired. So it becomes hard after drying, the biscuit state, but it is not fired. So if you put it in again into water, it dissolves again, and you can use it for another build, another object. So the point was that completely recyclable shapes. And also there was a funny thing here, like this spot here. Yeah, during the manufacturing of that lampshade, a calendar reminder popped out in this computer, so it paused for a while. And this was the computer mode and that being made. Actually, clay is very beautiful, but it's very hard to actually labor intensive to make this because you have something like that mud and you take with a spatula and take some material, put it inside, take some material, put it inside. It takes like an hour or 40 minutes to fill that water pipe that I showed. Yeah, filling this takes a lot. That's the only part that I don't like. And from this, these physical tries with connecting guitar to a printer and material things, I started to pass on to the digital part because, in a way, it allowed more freedom without labor-intensive things. So it started in these things. I started to investigate meaning and value of the things that are manufactured. If you have a chance, could you please go to od.falpi.com? I'll just show you a funny thing. Actually, these are, again, this is made for a course in a critic of design too, I guess. It was like transforming sound and motion into a form, and actually there was a setup like this. This vase is that's that. And the vase is sound and motion reactive. The bottom part of the vase responds to the lower frequency of frequency sound, and the top part responds to the higher frequency sounds. And if you make a high-pitched noise, like blow a whistle or something like that, it saves that instant state so that you can download it or make it later. And that same setup can also be used, for example, to transform sound instances. This is the same. Each of the forms that are saved there has a unique identifier number, and that file is saved, so you can take that email and read it. Obviously, there's a question like, this is not a creating something from scratch. It takes an initial base model and distort it. So there's also a question of how can we make something from scratch, maybe. And then it's made. You'll notice that there's some collapse after some point. Yeah, yeah, but it carries a lot, so you can make many things. Actually, there's a process that that allows also that integrates support structures to this clay method also, and also there's obviously 3D printing onto the powder bed of clay. That has much more potentials than this, but this is a cheap way to try many things. So what next lies in my studies? Actually, in the next stage of my PhD, actually it is still continuing, and I'm like always in the middle of nowhere. And but the question was like, after these trials and experiments and all these experiences, is it possible to manufacture an object that has connections to our past from the moment of its creation? So you make a thing, but it's instantly related with your past or something that belongs to you. Because in terms of our relation with objects, we are obviously we can have, for example, a meaning in the beginning only if, for example, that object is given by a relative or something like that, a present or an heirloom or things. Such things have obviously meanings inside. But what if we had that chance to make an object from the moment of its creation? So that passes on, like I'm now trying to forge meaning into form. It's related with the power of memories and personal needs. Actually, that's all for this presentation. That's another topic maybe I'll like to present in the future, maybe. And I hope that this presentation caused some ideas and questions in your head to take off. And thank you for listening. That's all. So I'm happy to answer any questions if you have. Yeah, sure.
Thanks for presenting that quite exciting. How do you extrude the chocolate and clay?
Actually, it's filled into a syringe-like thing. The chocolate was put into an industrial syringe, and with air pressure and then solenoid valve, yeah, the extrude command opens the air valve that forces pressurized air into the syringe, so that starts the extrusion. And when the extrude command is set to off, it closes that valve.
I see. The reason for asking this, especially in the clay one, the tube is quite huge, and the sound rate of clay is also important. Was it?
Actually, no, because I'm using like 2 bars of pressure in that tube, two and a half or something like that. So it's nearly impossible to. Without pressure, it's nearly impossible to extrude. And if you make it more, if you decrease the viscosity of the clay, or maybe it can create some problem. But also the nozzle should be wider, so that I don't know.
Maybe the chocolate in that clay tube.
Yeah, maybe it's like a combination of different parameters. So at some point, obviously, it can create a problem, but maybe for most of the builds, it will not create any problem. So, please.
May I ask what might be the motivation behind this? Is it just some sort of an policy satisfaction? I'm not into engineering for this. Is there a need for is there a customer?
Yeah, in terms of, for example, in the point that I came to, like attaching meaning and memories into the objects, actually there's a field that is very open and that cannot be exploited due to the conventional manufacturing systems, because yeah, the personal attachment to the products is another field of study and a wide field of study. And in order to increase the personal attachment to an object, there are various studies are made. For example, the material selections. For example, instead of plastics, the aging of wood becomes much more meaningful to most of the people, because in a way, to some people, becomes more beautiful because it starts to remind you some things. For example, dents in the onto the surface of that object may remind you of something. And also, if you use plastics, the surface coating might come off after some time. There are some degradations, color fade outs, and all sorts of things. These such defections or such time effects on objects start to become some reasons for getting rid of that object or product. So even if you manufacture a product that is, let's say, very high-tech or very complex or beautiful in the beginning, after some time, such things start to cause that the owner of the object to dispose that object. So it creates landfills, loss of functional electronics and such things. So actually, my motivation was like in the beginning, for example, in plugging a bass guitar into a 3D printer, I didn't think like, okay, this will make the world more beautiful, or I'll make a fantastic product that will solve many things. I didn't think like that. It was like an inner motivation, because I'm a bass player of myself, so it sounded interesting. It sounded worth exploring. Yeah, that was the main motivation in the beginning. So, but after some time, and I believe that after the completion of the thesis, it will lead to some meaningful and functional objects that has some function in the extension of the product life cycles and decreasing of the product disposal. I don't know, because I'm learning through this process. So actually, it will be not easy to say something about the future. Yeah, actually, yeah, in the middle of many work, trying to do that thing requires some enjoyment, because actually, obviously, most of these were done for the courses that I took here, but in the middle of those, I made some tries by myself, so that led to something another, and that led to something another. It progressed on like a journey or something like that.
What about financial resources?
Actually, it's financed by my work, mainly because I didn't have, up to now, I didn't think of applying to any grants or some things like that. But now I started to think about applying to some grants. So mainly that, yeah, because actually the reason that I built that machine was for work initially, but that led to other consequences also. So it's sort of self-financed itself, and I was not using very expensive materials and expensive machinery or something like that. Okay, we have an atelier in below floor, so I make most of them in there. So, but it's self-financed. Any other questions?
Thanks once again. This was very inspiring to listen to the presentation. I was wondering, how did you develop your mechanical side of these projects? How did you get the information? I mean, you mentioned YouTube, the all the forums.
I think I owe that to playing with Legos in my childhood, because I was like taking the set and without eating anything, I was trying to finish that. I'm in a way joking, but that helped a lot. So yeah, in terms of making the machine, yes, YouTube was the main source, but in 2008 there was not so much videos. So what I looked some patents for extruder head, for the controlling of extruder head, because I was using solenoid valves to control the extrusion process. But there are also some valves that are based on needles that break the flow. So I looked at those patents somehow. I found some companies that make such apparatus. For CNCs and all sorts of things, I made looks to the websites of the CNC machine makers, some do-it-yourselfers, and YouTube.
Yes, so you are basically self-educated yourself on this issue, right?
Yeah, sure. Actually, I was a science student in the high school, but I studied graphics design in university. So I passed on here in industrial design, but industrial design was always in my head. So in a way, in that machine, yes, obviously I self-educated, because in the beginning I had no idea of what G code is, what stepper motors are. I only had some basic knowledge in electronics, electric circuits, and I'm not a programmer also. But actually, that was all made possible with the open source nature of the things that actually it started with RepRap. So we owe a lot, I think, because of the when we think about the developments in the world related with this technology. I think many people owe a lot, because that enabled many applications to come to life. For example, the application to the surface of mirrors was one of them. So food and other things, because the companies do not always think that, okay, we can try this. The world became an experimentation lab with that technology, with the openness of that information. The world became the research and design lab. But normally, only companies have some confined research and design labs. Also, the forums are, I believe, that a fantastic place for this innovation and making new things. Because I also read many forums, and I realized that people in Turkey, I'm very sad that we most of the time are very hesitant to share our knowledge, because it also occurred to myself, so I can say based on that experience. Because there are many opportunistic people that can exploit that thing we think, but maybe I started to think that maybe it's not that bad, so why not share? So actually, this is the Mirror Fabrica brand is like mostly known for its handmade mirrors. We didn't expose the 3D printing thing, because obviously it still has some handmade features, some processes. But this is the first time that I publicly spoke about that of that brand. So it's on also Hangouts, Google Hangouts. So I don't know who watches, if anyone watches it.
I don't know.
Yeah.
Did you fail a lot? I mean, I think you must have failed a lot, but kept going, trying. How did you get the motivation?
Yeah, of course I failed. When I failed, actually, the biggest question in my head was, these electronics were made for this size machines and the motors and all the plants. So the biggest question was, will it work in such a big sized machine? Will the motors be sufficient to drive such a huge gantry, that inertia, and all these things, and also the electronics? So I tried, and it worked. But in the beginnings, the biggest problem was the controlling of the flow of the material because of the valves. There were air bubbles. That was a problem. I couldn't get rid of air bubbles and that kinds of things. After some time, I failed somehow because the machine was skipping steps because of the weight of the machine. So another problem that I faced was in the beginning I was using the RepRaps slicer, the replicator G, and it took in order to create the tool paths for the mirrors, I was making the extruded version of the pattern and then slicing that, but that extrusion was 1 millimeter high, and in the slicer program the height was 1 millimeter. So I ensured that the machine goes on top only once, not more than once. So those were the initial problems, and it took a lot of processing time, like 20 minutes for a single build. And I had not much control over the tool paths, but after I passed on to Rhino and Rhino Can, it was solved. And in terms of materials, like, actually, as you see, I didn't pursue like, okay, I'll make a statue out of chocolate. I didn't pursue such a thing, but yeah, just because of time, and also, okay, I have the experience now. I can maybe try another thing or kinds of thoughts. So it progressed. I don't know. Many things are left half maybe, but yeah, that's self motivation, I guess. I don't know. Good. Thank you for listening.